Hi everybody. This is a problem from our homework that I wanted to go over with you. It says a motorboat moves 21 miles per hour in still water and it travels 14 miles upstream and then 14 miles downstream in a total time of 1.5 hours. The question is, what's the speed of the current? Now, since it asks for the speed of the current, let's right away write down that that's what my variable is. Let x equal the speed of the current. Now I know there's two motions here. There's a motion going upstream, and if he goes upstream, then he's going to be going against the current. And so instead of going 21 miles an hour that the boat goes in still water, he's going to be going a little slower. 21 minus x. 21, the speed of the boat, minus the speed of the current. That'll be the speed upstream. And then likewise, when he turns around and goes back, he's going to be going a little further because the current will carry him along a little faster. So 21 plus x, that's the speed going downstream. Okay? Now, as in all these motion problems, we want to organize our information in a nice little box here because there's really 6 variables in this problem. And we need a way to organize and keep those straight. So this helps us to do that. Alright, so I have the motion upstream, and then I have the motion downstream. And for each of those motions there's a rate and a time and a distance, and I know that the rate times the time equals the distance. Well, I know in each case he goes 14 miles upstream and then 14 miles downstream, so the distance is the same in both of them. The rate upstream we just set up here, that's 21 minus x. The rate downstream is 21 plus x. Now I also don't know the time, but notice the time is not 1.5 hours for either one of these because it says it's the total time. So it's going to be something less than 1.5 hours going upstream and then something less than that, but together those times are going to add up to be 1.5 hours. Okay? Well, since the rate times the time is equal to the distance, all you have to do is divide both sides by the rate, and you'll see that the time has to be the distance divided by the rate, right? So this time upstream, whatever the rate happens to be, I know the distance is 14, so the time has to be the distance 14 divided by the rate 21 minus x. And likewise, the time downstream has to be the distance downstream, which is again 14, divided by the rate downstream, which is 21 plus x. Okay? So again, what I know is that the total time is 1.5 hours. So I know that this time upstream plus that time downstream has to add up to be the total there of 1.5. So 14 over 21 minus x plus 14 over 21 plus x, that has to equal the 1.5. Alright, so let's go ahead and work this out. That's hopefully the hard part for you. Let's multiply both sides by the common denominator, which will be 21 minus x times 21 plus x. We'll do that on both sides. Alright, so over here on the left hand side, when I distribute this right here to the first term and then to the second term, you can see that when I distribute to the first term, the 21 minus x's will cancel and I'll just get 14 times 21 plus x. Okay? And then I'll go over the plus sign, and then the 21 plus x's will cancel, and I'll get 14 times 21 minus x. And over on this side, I'm going to get 1.5 times this, and this is one of those special products. Right now, I've forgotten what 21 squared is, so let me open up my little handy-dandy calculator here and see what that's going to equal. All right, so 21 squared is 441, so this is going to be 441 minus x squared. Alright, so let's go ahead and distribute. Let's get the 14 times 21. I forgot what that was too. That's 294. So I get 294 plus 14x plus another 294 minus 14x. And that's going to be whatever 1.5 times 441 is. So let's figure that out. That's going to be 661.5 minus the 1.5x squared. Okay, so it looks like the over on this other side, the 14x's, they'll cancel. So let's take everything over here on the left. So I get a positive 1.5x squared. And then I got 294 and 294, and then I'll have to subtract the 661.5. All right. So let's take 294 times 2. That'll be these two 294s. And then I want to subtract from that the 661.5. That gives me minus 73.5. And that leaves me 0 on the right. So let's see if 1.5 doesn't divide into 73.5. So let's divide that by 1.5. Oh, that's very good. That's wonderful. Okay, so let's go ahead. Let's just divide it out rather than factoring it out. Then it just goes away. All right, so now I know that x squared minus 49 is equal to 0, and I can factor that one pretty easy. So my x is either a negative 7 or x is a positive 7. Now you remember my original problem, I said x was the speed of the current. So a negative speed of the current, that one's not going to be reasonable for us. And so my answer is that the speed of the current is 7 miles per hour. Okay.